Okay, folks, we're gonna go through Unit 2. I think reprint these. This is actually Unit 2. We're going to kind of skip over lessons 1, 2, and 3 for timing purposes. We're going to move on to lessons 4 and 5. But the idea, I'm not going to worry about the warm-up, but we're going to do some vocabulary here to kind of start out. We're going to talk about a new type of transformation called a dilation. This is when you, I should actually be able to write the word "you" before moving on to the next word. When you make a shape bigger or smaller. That's all. Okay. It's going to be the same shape, but it'll be different sizes, right? But we'll talk about that kind of like as we get into other vocabulary words. I don't know if you had something like this here. You have A, B, C, then something like this. You know, A prime, B prime, C prime. So it's getting bigger right there. Now, how you actually make this bigger is something called the scale factor. The variable we use for this is k, so I'll kind of use those interchangeably, whether I'm talking about scale factor or k. The scale factor is the number, it's basically how much bigger something is than its preimage. How much bigger or smaller an image is than a preimage is compared to a pre-image. So if I say that our scale factor is 2, right, that means a shape is 2 times bigger than another shape. Okay, and how you use this scale factor is typically you will take the original shape, all the points, and you will multiply all of them by the scale factor, whether it's 2 or 1/2 or 1/3 or 3 or 4 or 7, right? Yeah, anyway. Yeah, so center of dilation is the point from which a shape dilates, right? So the idea is it will either, for an enlargement, move away, or for a reduction, getting smaller, right, it will move towards. Okay, so if I have like, this is my center of dilation right here. Let me actually make a better arrow that actually points to it. Okay, so if I have like a square here, right, then this is the preimage. Okay, and it's getting bigger. Okay, it's going away from that center of dilation. And then now we get to this word similar. This goes back to, when you make a shape bigger or smaller, it's going to be the same shape but a different size, right? So the but different size. Now the idea here is that it'll have the same angle measurements, right, the image and the preimage, but the sides will be in proportion rather than the same. It will be proportional, let's say. Proportional rather than the same length. Right, so when we talked about rigid transformations, right, they were exactly the same shape and the same size, but now the sides are going to be proportional. Basically, you're multiplying each side by the scale factor, by the same scale factor. as your things, right? So if we kind of like are referring to, A, B, C, and A prime, B prime, C prime, right, as our kind of original example for this, we would say that triangle A, B, C is similar to triangle A prime, B prime, C prime. That symbol, that little wave there, like kind of the tilde, if you speak Spanish, that's kind of where you would find it on a keyboard. It just means is similar to. So these two shapes are similar because they're the same shape, but different sizes. The sides are in proportion to each other. Okay, I'll kind of zoom that out. If you need to pause it, so make sure you have it. Okay, I'll zoom it out and focus it right there. Okay, cool. Yeah, pause that if you need to, and then kind of we'll move on over here. Okay, now let's dig into scale factor a little bit more. When your scale factor is less than 1, basically meaning a fraction, typically, or like a decimal. Right, like it could be like 1/2 or 0.5. This just means it's a reduction, okay, and it's moving towards the center of dilation. Okay. Now, when your scale factor is equal to 1, that just means you're multiplying the whole thing by 1 rather than like 1/2 or 0.5. So the size is going to stay the same. We're not going to see really any examples about this, but I just want to say that if there is a scale factor of 1, your size will stay the same, right? We're not actually going to get into calculations of this, but just want you to be aware that you can technically have a scale factor of 1, we just won't see it very often. Now when you have a scale factor of greater than 1, right, this just means it's an enlargement, so it's getting bigger, and your shape will move away from the center of dilation. Okay, now we'll get into some actual dilation here. We basically have the same figure 3 times, but we have different scale factors. Okay, so we have an enlargement here, we have 2 reductions, and we have different centers of dilation. So we have R here, we have O here, and then we have S on this one. So I'm gonna just kind of like highlight the center of dilation on each one so I know where I'm going from. So this is from R, this is from O, and this one is from S. Okay, now from S over here. So this is an enlargement, so it's getting bigger. And this is getting smaller. Okay, this has the same scale factor, so it'll be getting smaller, but it'll look different. These two will look different because you have different centers of dilation, right? So it'll be moving towards this S, but this one will be moving towards the O. This one will be moving away from the R because that's an enlargement and moves away from your center of dilation. A lot of times your center of dilation will be the origin at 0, 0, but not all the time, right? So you just gotta be able to kind of deal with it. And you deal with it in the same way. When you don't have any coordinates like this, basically you count how far each point is away from your center of dilation, and then you multiply that by the scale factor. So in this case, we'll basically double it, right? So I take a look at R as my center, and then I go to Q first, right? I can see that it's 1 up, and then 1, 2, 3, 4 over. So Q prime will be 2 up and then 8 over, because I'm basically doubling the vertical distance and I'm doubling the horizontal distance, right? So I go up 2 and then I go over 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's going to be Q prime right there. Ooh, let me make sure I have a straight edge somewhere. Okay. And, one thing that you should notice, well, I'll compare these. We'll go with this. Okay, so P, if I compare it to R, it's 1, 2, 3 up and then 2 over. So from R, it'll be 6 and 4, because I'm basically doubling that vertical distance. and the horizontal distance. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4. That's P prime right there. And then S is 2 up and 2 over, so it'll be 4 up and 4 over as I double it, because that's my scale factor of 2. So 1, 2, 3, 4 up, and then 1, 2, 3, 4 over. Okay, so I've got my new shape here. It has been enlarged. You'll notice that this line out to Q prime is the basically the same, on the same direction, I suppose, as that, as is S prime. The reason that is because R is, and R prime technically, are the same points, right? Basically the center of dilation is on the shape, so that point will kind of stay the same. And then I'll connect these two here, and then S prime to P prime right there. So we can see that that shape has gotten bigger. It has doubled in size. So if we kind of like summarize what we did here, or if we talk about things, right? So R is on the shape. Let's say R is a vertex. Okay. So R prime will be in the same spot. Because R is the center of dilation. Okay, so just kind of like a persnickety thing there. Another thing that I kind of want to mention is that you're basically doubling the distance vertically and horizontally from the center of dilation. Okay, and that's kind of what I did when I counted the distance from it, right? So R to P, right, is 3 up and then 2 left. So then the distance to P prime is going to be 6 up and 4 left. 3 times 2 is 6. 2 times 2 is 4, right? So that's kind of like how that happens. Okay, so now we're going to have a reduction as we are shrinking our shape. It's getting smaller. So from O, which is my center of dilation, if I count to Q, right, that's 1, 2, 3 points away. So half of 3 is 1.5. So that's going to be right there. And it's straight up, so I don't need to like change the, the horizontality of it. Okay, R is up 2 and over 1, 2, 3, 4. I cut those in half. I go up 1 and right 2. Okay, so you'll notice that first one is kind of in the middle, but this one should be on the grid. And then S is 1, 2, 3, 4, 5 up, and then 1, 2, 3, 4, 5, 6 over. So it's going to be up 2.5 and then right 3, because I'm cutting it in half. So 1, 2.5 and then 1, 2, 3. So kind of like right in the middle of the shape there. And then P is 1, 2, 3, 4, 5, and then 2 over. So it's up 2.5. 1, 2. Did I get that right? Hold on. 1, 2, 1, 2, 3, and then over. Oh, my bad. So S is 3 up, so it's actually going to be 1.5 and then 2 over. So S is actually going to be 3 over. Golly, sorry about that, guys. Because it's 1, 2, 3, 4 up, and then, oh, hold on, S. 1, 2, 3, 4, then 1, 2, 3, 4, 5, 6. Oh, my bad. It's over 2 and, sorry, up 2 and over 3. Golly, I'm sorry, guys. That was easy. It wasn't an odd one, but this one is an odd one. So 1, 2, 3, 4, 5, and then 2. So it's up 2.5 and then over 1. So P prime is like right there. So that's our shape right there. Okay. Yeah, let's double check. 1, 2, 3, 4. Yeah, that's right. Yeah, so our shape is right there. You can see that it got smaller. So it's moving towards the center of dilation. and you basically divide the distance in half. Distance from, I'm actually going to call that COD, distance from center of dilation, not code, COD, in half from the pre-image, right? So again, that's that counting from the origin, right? If I do S again, right, I count up to S, I go 1, 2, 3, 4, up, and then 1, 2, 3, 4, 5, 6 from that center of dilation. So it's 4 and 6, so I cut it in half to be 1, 2, and then 1, 2, 3 right there. Okay. Something similar here, but rather than having the center of dilation outside of the shape, it is on the edge of the shape. Pretty similar to this, right? You can see that it's outside the shape here, but because the center of dilation is outside the shape, but it kind of like overlaps this because the center of dilation is on the vertex. So it's a similar situation here, but it is a reduction rather than enlargement for this third one here. So if I compare R to S, it's 2 left and 2 down. So half of that is 1 left and 1 down. So that's going to be R prime right there. And then P is 1, 2, 3, 4, and up 1. So it's over 2 and up 1. So P prime will kind of be on the line right there. And then Q is 1, 2, 3, 4, 5, 6 left and down 1. So it'll be left 3 and then down a half for Q prime. S prime will remain in the same spot. I'm just going to kind of freehand the lines there. And yeah, and you can see that because the center dilation is on a vertex, the shapes will overlap. The image and the pre-image will overlap. Again, it's moving towards center of dilation. It's because it's a reduction. Let's see, what else can we say? And the same thing, we divided distance from the center of direction in half, or center of dilation in half from the pre-image. Obviously, it's not always going to be half. Sometimes it'll be a third, so you'll be dividing in 3 rather than by half. What else can we say about this that we haven't said, like in the previous one? Center of dilation is on a vertex, so shapes overlap. So the image and pre-image will overlap. Okay, yeah, that's about it, guys. Yeah.